Hello everyone, this is Mr. Osama, Math Department, Sunrise International School. Today inshallah we are going to talk about some exercise for chapter 4 lesson 5, which is called the isosceles and equilateral triangle for grade 8 geometry. We had the previous video for this session, which is explanation. Today we are going to talk we are going to take some exercises to cover what we had. So today I'm gonna do some exercises. Exercises for chapter 4 lesson 5 grade 8. We need to start off with the first example, which is question number 1. In the given figure here, triangle EFD is a regular triangle, has kinematical conditions, which is measure of angle E equals 61, measure of angle D equals 58, and the question required if DE is congruent to segment DF. We need to find out this. So I'm going to get back to the plain paper and start doing this. I'm going to move this up a little bit, and then I'm going to draw the triangle here. So this is the triangle which we're looking for. The triangle has some kinematical condition here. This is vertex E, this is vertex F. I'm gonna get back again. This is vertex E, F, D, E, F, and D. The given information here, 61 degrees for this is one, and this is 58 degrees. 58 degrees. We need to find out if the segments, according to the question here, DE is congruent to DF. So we need to find out if DE segments congruent to the DF segments. Back again to the figure. So I'm gonna say here, according to the given information, which is kinematical conditions, measure of angle E equals, so I'm gonna say measure of angle E, since measure of angle E equals 61 degrees, measure of angle D equals 58 degrees. We had an axiom before stated that the sum of all interior angles of any triangle is equal 180. So I'm going to say measure of angle E plus measure of angle F plus measure of angle D equals 180 degrees. We do the plug into and find out the missing, which is angle F. So I'm gonna say measure of angle F will equals 180 minus 58 plus 61 degrees, and this will give me the value of angle F. So measure of angle F, I'm going to change the color. So measure of angle F, measure of angle F will be, I'm gonna use my calculator to find out what is the result here. So I'm gonna say 180 minus 58 plus 61. So the result will be 61. So the measure of angle F 61 degrees. Measure of angle F equals 61 degrees. 61 degrees. According to the theorems which we had for the previous session, for the previous video about the same session, that if the triangle contains two congruent angles, then the opposite sides of those triangles are congruent. So right now we can say that the DF is opposite to E and DE opposite to F, and both E and F are congruent. So I can say that segment DE is congruent to the segment DF by the theorem which we had before according to the definition of the isosceles triangle, which is 4-3, which is theorem 4-3. Theorem 4-3. And this will complete the answer for the first example. We need to go back to another example, so I'm gonna move to the next example here. In this figure in front of you here, there is a triangle has been given, and it shows that this triangle is isosceles triangle, which has two congruent sides, has been illustrated on the figure. The question required to solve for x. What do we mean by solving for x? Is to find out the value of x. So I'm gonna work with two things, geometry and algebra at the same time. So geometry, I'm gonna take the property of the isosceles, then I'm gonna establish an equation and then solve this equation for x to find out the value of x. So I'm gonna get back to the plain papers, which I'm gonna start with. So I'm gonna draw the triangle again, a regular isosceles triangle. So I'm gonna go up a little bit. I'm gonna go up a little bit. Exercise number 2. So I'm gonna use this here. Exercises number 2. A regular triangle, isosceles triangle. The isosceles triangle has been given. Two segments are congruent. So I'm gonna get back to the given. The perpendicular distance has been given here. So I'm gonna change the color to make it red. So this is perpendicular distance, and I'm gonna use the given information, which is the left hand side angle is gonna be 5x. So I'm gonna write down here 5x. This is 5x, and the other will be 3x plus 28. 3x plus 28. 3x plus 28. How can we solve for x here? According to the given figure and the kinematical condition states that this triangle is an isosceles triangle. So I'm gonna get the conclusion from the theorem which we had, that the base angles are congruent. So I'm gonna write down here, since triangle is isosceles, then the conclusion would be measure 5x equals to 3x plus 28. So I'm gonna solve for x. I'm gonna solve for x. So I have to, I'm gonna change the color. I'm gonna minus 3x from both sides. So minus 3x here, minus 3x here. This will cancel each other, and the remainder will be, this is cancel each other. The remainder will be on the left hand side 2x, the right hand side will be 28. Then I'm gonna divide it all sides by 2, divided by 2. I'm gonna move up a little bit. Once you divided the left hand side by 2, the result will be x. The result will be x equals 22 divided by 2 is gonna be 14. So I got the value of x, which is 14, and this will complete the answer for the question number 2. I hope you guys got the question and how to solve it. We need to move to the next question, which is question number 3. Question number 3 states that you have isosceles triangle XYZ has base XY segment and M, measure of angle Y equals 34, and what is the measure of angle Z? So I have to draw the triangle, and then I have to get from the kinematical condition and the theories and the properties of the triangle the requirement. So first of all, I need to get back to the plain papers to draw triangle XYZ and the base XY. So I have to make sure that the base is XY. So I'm gonna go up a little bit. I'm gonna use the smart here. So I have a triangle here. This triangle is isosceles triangle. I'm gonna get back to the given information from the figure. The base XY. So I'm gonna see here. This is X and this is Y. Well, it's a base, and this will be Z. So the triangle XYZ has the base XY and measure of angle Y. Measure of angle Y is 34 angle Y. 34 angle Y, and the triangle is isosceles, and we need to find out the measure of angle Z. So once they said this is the base, the legs are congruent. The legs are congruent. So I can get a conclusion here. Since triangle XYZ is isosceles, then the conclusion will be XZ segment is congruent to YZ segment. Why? Because the base is already exists, which is XY. So according to this, I can say that base angles, I have to write down, then the conclusion will be base angles are congruent. I'm gonna move up a little bit. So I'm gonna say, so measure of angle X equal to measure of angle Y, which is 34 degrees. To find out measure of angle Z, we need to use the sum of all interior angles of a triangle equals 180. So measure of Z plus measure of X plus measure of Y equals 180 degrees. So measure of angle Z equals 180 minus 34 plus 34. So measure of angle Z, which is required, equals to, I'm gonna use my calculator to find out the value, 180 minus 34 multiplied by 2 or plus each itself. So the result will be 112, and this will be the final result of this example. So I hope you guys got to understand what we've been through. Thank you for watching the video, and I hope you guys understand what's been through. Have a good day, and we'll meet you again inshallah in the next video. Have a good day and goodbye.